Hi, class. We are going to the beauty of recorded lectures. I know this is not ideal. We have to do what we have to do and have to adjust and go with the flow. And for this Tuesday, before Thanksgiving, we just need to go with the flow with what's going on with the church and their need to have a funeral there and things like that. So I am grateful that you're here with me, even if it's just on a pre-recorded lecture. And I just wanted to do a few things to talk with you about. So first off, last lab we did a review session, right? We reviewed all about rocks and minerals. That's what we did. We reviewed what we know thus far about rocks and minerals, and now we're going to go on to the Mohs scale of hardness. Mohs is spelled M-O-H-S, okay? The Mohs scale of hardness and streak tests. So this right here is the Mohs scale of hardness, okay? And that's how they determine how hard or soft minerals are. Friedrich Mohs, a German mineralogist, developed the scale in 1812, so a long time ago. He selected 10 minerals of distinctly different hardness that ranged from a very soft talc to a very hard diamond. Okay, with the exception of the diamond, the minerals are all relatively common and easy or inexpensive to obtain. And I have actually obtained them. So I'm going to post another video later of Matthew and Joe doing the activity that we're going to do. But these are the minerals they use in the Mohs scale of hardness, except for diamond, because it's obviously too expensive to put on here. So these are them. And we're going to do the Mohs test with them. And you scratch them with different materials, which we'll find out to see how they scratch. Okay? So hardness is the resistance of a material to being scratched. The test is conducted by placing a sharp object, or the sharp point of one specimen, on an unmarked surface of another specimen and attempting to produce a scratch. So here are the 4 situations that you might observe when comparing the hardness of 2 specimens. If specimen A can scratch specimen B, then A is harder than B. If specimen A does not scratch B, then B is harder than A. Okay? If the 2 specimens are equal in hardness, then they will be relatively ineffective in scratching one another, right? That makes sense. Small scratches might be produced, or it might be difficult to determine if there's even a scratch there. If A can be scratched by B, but cannot be scratched by specimen C, then the hardness of A is in between specimens B and C. Okay? Hardness testing is done by scratching one mineral against another. To get the most accurate results, a sharp edge should be scratched against a smooth surface on a small an area as possible. The scratch should not be conducted on a surface that is coated, chipped, or weathered, for it will give inaccurate results, okay? And that is important to do. When a mineral is scratched, a permanent indentation is created. Powder of the softer mineral will come off and it will cover the scratch area. This powder needs to be brushed away to see if the mineral really got scratched, or if the powder of the softer mineral that was swiped across the specimen being tested created a scratch-like mark. When minerals of similar hardness are scratched together, it is difficult to tell which mineral, if not both of them, is really getting scratched because of this. Most minerals are anisotropic to a minor extent, meaning that their hardness varies in different directions. Kyanite is famous for this habit. When scratched in one direction, it exhibits a hardness of 4 to 5, and when struck from a perpendicular direction, it exhibits a hardness of 6 to 7. Kyanite is the only mineral exhibiting such anisotropism. In virtually all minerals, the anisotropism is so weak that it can't be determined. So, there's a scale of some common minerals determined by the streak test and the Mohs scale of hardness. And these are, you've got common minerals. Okay, I'm going to show you this again. Like you've got diamond, okay, corundum, topaz, quartz, orthoclase, apatite, fluorite, calcite, gypsum, and talc. Okay, I don't know if you can see that. Hopefully you can. So diamond is the hardest at 10. The softest is talc, okay? And you use different things like your fingernail, a penny, a nail, or a steel file to scratch these minerals. We're not going to scratch the minerals against each other. I will use these different materials to scratch the minerals and determine their hardness and to show you what they do. Okay, I also posted a video of another woman doing it as well on our haiku page. Okay, so every mineral is able to scratch the ones below it and get scratched by the ones above it. So if we did rub together talc and gypsum, they'd be able to scratch each other, right? and they're both pretty soft, so they both scratch each other. Calcite would scratch the gypsum. Okay? So that's our scale of hardness. Okay? Now we're going to talk about streak. All right? So streak testing is a method used to determine the color of a mineral in its powdered form. Remember, color, you can look at a mineral and be like, oh, hey, this is blue. Okay, but there's other blue minerals. Other blue minerals. But if you scratch it along the scratch plate, the mineral powder will be a different color sometimes. Actually, quite a few of the times. And a lot of them are white. But depending on the color of the powder, you can also help narrow down the identification of the mineral. Okay? So, the color of a mineral's powder is often a very important property for identifying the mineral. The streak test is done by scraping a specimen of the mineral across a piece of unglazed porcelain known as a streak plate. Let me get out. Where's my handy dandy streak plate? I had one. This is a streak plate. Okay, so that's what we are going to do in our in-person portion. And like I said, Matthew and Joe are going to do some minerals. We're going to do our scratch test on the streak plates, okay? And you use the plates to streak the mineral across it, okay? And this is a streak plate. It's porcelain, okay? And it's unglazed. This can produce a small amount of powdered mineral on the surface of the plate. The powder color of that mineral is known as its streak. The streak test is valuable because many minerals occur in a variety of apparent colors, right? That's what I said, but all specimens of that mineral share a similar streak color. So for example, hematite can be black, red, brown, or silver in color, and it occurs in a variety of habits. However, all specimens of hematite produce a streak that is reddish color. So it helps make sure it's actually hematite, okay? So it comes in all these different colors, right? It comes in black, red, brown, or silver, but they all streak. All of them streak. Their powder is a reddish color. So that's how they can be sure, a geologist can be sure, hey, this is actually hematite. Because it might look like a different mineral, right? So it's really important to do the streak test. It's a valuable test for hematite. It can be used to differentiate hematite from a large number of other opaque minerals with a high specific gravity and similar color and habit. Crystal habit is the tendency of specimens of a mineral to repeatedly grow into characteristic shapes. Okay, these shapes are influenced by the atomic structure of the mineral. They can also be influenced by the environment of the crystal growth. Regardless of influence, crystal habit shapes are characteristic of the mineral and displayed by many specimens of that mineral. Fluorite is another mineral where the apparent color can be different from the color of the streak. Specimens of fluorite can be green, yellow, blue, purple, or colorless. Okay, so I'm going to show you. Let's see if I can find some fluorite in here. I'm sure I can find a picture of fluorite. So here, look at fluorite comes in. There's copper. But look at the fluorite. Look at all the different colors of fluorite you got here. So if you've got all these different colors of fluorite, and they also look like quartz and other things, and you're not sure, hey, is this fluorite? Then you do the scratch test, okay? And when you do that on the streak plate, they all have a white streak. All fluorite has a white streak, regardless of the color, okay? So again, the color can be varied. It can be yellow, purple, green, or blue, or colorless, but the streak is always white. All right, this is why the streak test is so valuable. Specimens of pyrite also have a brassy yellow color. However, all specimens of pyrite produce a black streak. Okay, so that is the Mohs scale of hardness, okay, and our streak. And there are videos up on how to do both, how to do a streak test and how to perform a mineral hardness test using the Mohs hardness scale. And I will also be posting a video of Joseph and Matthew and I running these activities like we would have in class. I'm really sad. I really want to do this with you in class. However, we're just going to have to make do and do this class online and go from there. And the following week, please, next week, week 12, please bring an old sock and a hammer. We're going to be breaking open geodes. This is going to be our geode week. Week 12 is. So please bring an old sock and a hammer, all right, so that we can go ahead and see what's inside our geodes. I'm pretty excited to break open some geodes and talk about geodes. They're pretty fascinating. I hope you all have a blessed Thanksgiving. I really enjoy teaching each of you. Also, please remember that in weeks 13 and 14, we're going to be giving our presentations. It's time to start getting those ready. poster board, a Google slideshow, a PowerPoint, any kind of presentation with a visual aid, 3 to 5 minutes on your topic. Please be ready. On week 12, there'll be a poll saying if you're going to choose week 13 or week 14 to do your presentation. Okay? I look forward to seeing you all again face to face in a week, Lord willing. And I hope you guys have a blessed Thanksgiving. Have a great, great week, you all. Thank you so much.